Hey guys, so this week we're also learning about transformations, but we're only going to focus on quadratic functions. Quadratic functions are really important in Algebra 1, and then as we go into Algebra 2 later on in high school. So we're going to do the same thing we did this week. We're going to just focus on one type of function. Okay, so our first thing we're going to do, we're going to look at our objective. We have some key points and some things that we need to remember before we start looking at examples. There are also opportunities for you to try solving some of these problems on your own. When we get to the you try part, what I want you to do is pause the video, think about what the answer could be and try working it out. If you need to, write it down on a scrap piece of paper. So you might want to grab some paper and something to write with right now, and then come back and finish the video. And then when you finish what you think is the answer, or you get as far as you need to, then all you need to do is hit play and go ahead and keep going. Okay, so our objective this week is that you're going to be able to describe and sketch the transformation of that quadratic function specifically in vertex form. That's the easiest way to graph. So if we look over here, up on our top area, we have our vertex form of a quadratic function. Notice that since the highest exponent that appears there is squared, that's why it's categorized as a quadratic function. So vertex form has that coefficient out front. We use A, and A stands for a coefficient that represents how it changes the graph, whether it narrows the graph or widens the graph up. So we call that vertical stretch. On the inside here in our binomial with x, that h represents our horizontal, so left to right transformation. If it's minus h, it's going to go to the right, and if it's plus h, it's going to go to the left. Side note, x equals h is your axis of symmetry. So that very center of your graph, that's where we could fold it, and it would fold right onto itself because the graph is symmetrical. Also, that point is the x-coordinate of your vertex. And then lastly, we have plus k on the outside, and that represents our vertical transformation. So whether it takes it up or down. And then just as another side note, our vertex is represented by h comma k. So we look at that h that's on the inside with x, that's our x value of our vertex. And then we have k on the outside, that's the y value of our vertex. Also, I wanted you to remember that the domain for every single quadratic function we've ever looked at this year and are ever going to look at this year is all real numbers. And then our range is either going to be whatever k is that comes from our vertex to positive infinity, so meaning it's greater than or equal to whatever k is, or negative infinity to k, so that k is that number is in our vertex representing the y part of our coordinate. So if it's flipped over, it's going to be less than or equal to whatever that is. Okay, so some key points here. If we're moving our graph vertically, meaning we're going up or down, if k is positive, so if plus k on the outside, your graph's going to go up, however, whatever number that is. So if k was 2, your graph would go up 2. If k was plus 3, your graph would go up 3. Now, on the other side of that, if k is negative, your graph's going to go down. So if it's minus 2, that means your graph is literally going to be picked up and then taken down 2. If it was minus 5 on the outside there, you would literally just take your graph and move it down 5. Okay, now if we're going left or right, this is where it gets a little bit tricky. If it's plus h on the inside of that binomial with x, we're actually going to go to the left. A lot of times it's really easy to think, oh, plus, I'm going to go plus on the x-axis, but you're doing the opposite of what's happening. So if it's plus 4, you're going to move left 4. You're literally taking your graph and you're moving it left. And then if it's negative, meaning it's minus h, your graph is going to move to the right. So here's our first example. We're going to graph our quadratic function f at x equals x squared. And we're actually going to translate it 3 units to the right, and we're going to vertically stretch it by a factor of 4 and we're going to move it 2 units up. We need to write that formula that defines that transformed graph. So what's really important to look at here is that we need to look at, we're looking at 3 units to the right. That's important. We're looking at stretching it vertically by a factor of 4, also important. And we're moving it 2 units up. So let's look at one thing at a time. That's step 1. We're starting with our parent function. So that's f of x equals x squared. Now we need to do a horizontal translation. We need to move it to the right. So we have to do minus from x. And it goes inside the parentheses with x because it's a horizontal translation. So it's going to be x minus 3. That whole thing goes in parentheses, and it's a quadratic. So the x term must be squared. So the squared goes on the outside. Next, we're going to add on our vertical translation. Vertical meaning we're going to go up or down. In this case, we need to go up 2. So on the outside of my squared term here, my quadratic term, I'm going to put plus 2 because I want my graph to go up 2. Lastly, we had to have a vertical stretch. And so since it's being vertically stretched by a factor of 4, any type of vertical stretch where it either narrows or widens my graph, I put that on the outside as a coefficient to my quadratic term. So in this case, my quadratic term is all inside parentheses squared. So all I have to do is take whatever factor I'm stretching my graph by and put it right on the outside there. So if I put it all together, my new function or new equation is going to be f of x equals 4 times the quantity x minus 3 squared plus 2. My next example, I need to identify the vertex of this equation. Now, remember, this is in vertex form, so it makes it really easy here. I have x minus 3. This is going to be the x part of my vertex, and then I have plus 2. This is the y part of my vertex. So I'm going to put it all together. Here's the x part. That's going to be 3. And then my y part is 2. I'm going to put that in an ordered pair. That's really important. It goes in an ordered pair. X, then y. Remember, alphabetical order. X comes first in the alphabet. So in an ordered pair, x is also going to come first. So we think x first. The way my graph is changing on the x-axis is by 3, and then it's going up by 2. So my vertex is 3, 2. So here's a you try. I've given you 4 different things I want to happen. I want you to look through these things. I want you to pause the video and try your best to write an equation in vertex form of this quadratic. And then when you think you got it, I want you to hit play again and see, and then look at the example and the answer and see if you got it. So we're going to do what I just did a moment ago, my first example. And I want you to write an equation for the function that defines the described transformation of the graph of a quadratic parent function. So the quadratic parent function is f of x equals x squared. The first thing I need you to do, you're going to shift 3 units to the right. So think, do I need to do plus or minus? I want you to vertically shrink your graph by a factor of 0.5. I want you to reflect over the x-axis, and I want you to go 4 units, and I want you to shift up. So hit pause, and then hit play again when you think you have what the answer is. So here's the answer. I have my vertical stretch here. Now I have 2 things that actually were here because I wanted it reflected over the x-axis. So that meant that this whatever number was on the outside as my coefficient had to be negative. And now I have my factor that is shrinking my graph by, and that's 0.5. So I have negative 0.5 as my new coefficient on the outside of my quadratic term. I wanted my graph to go 3 units to the right, so I had to use minus because it's the opposite of what I thought it would be. So on the inside, it's minus. I wanted to go 3 units, so it's going to be x minus 3 squared. And then I wanted my graph to go up 4, so I have plus 4 on the outside. So here are some more you tries. And so I'm going to keep going through these questions, and feel free to hit pause and play as you go through them to see if you got them right or not. So the first one is, what are the transformations from the parent function y equals x squared if the new function is y equals the quantity x minus 2 squared plus 4? So the answer is it's going to move up 4, and it's going to go to the right 2 because it's minus 2. Okay, next question. If the given equation y equals 3 times the quantity x plus 5 squared minus 4, what is the vertex of the equation? I remember I need an ordered pair, x comma y. What are the numbers that are going to go there? So my vertex would be at negative 5 comma negative 4. I have a negative 5 here because if I were graphing this, this would represent x plus 5, a translation to the left. So normally my parent function is at 0, 0 at the vertex, but I've now moved 5 to the left, and that would make it sit at negative 5. And then it would go down 4, so my vertex is at negative 5, negative 4. Okay, this was a multiple choice question. So I want to know what would cause my graph of the parent function, my quadratic parent function, y equals x squared, to open down. Normally, remember, it opens up like this. How would I make it flip down so I have a u, an upside down u instead of a u? So would I multiply the x squared by a fraction? Would I multiply that x squared by a decimal? Would I multiply the x squared by a negative number? Or would I multiply the x squared by a number greater than 1? So go ahead and pause, think about it. When you think you know if it's A, B, C, or D, go ahead and hit play and see if you're right. So the answer is C, a negative number, so a number that's less than 0 will cause your graph to be flipped over. And our math word for that is reflected. We actually reflect it over the x-axis. Okay, our next multiple choice. Which of the following could be the correct equation for this graph? I want you to first notice, look at all of our answer choices here. 2 of them have negative coefficients, 2 of them have positive. None of them have other numbers in front. So we really need to pay attention to the negatives. Should it be negative or should it be positive? And then we also need to pay attention to our vertex here. So go ahead, look at the graph, look at your answer choices. When you think you've got it, go ahead and hit play and see if you're right. So the correct answer is C, because our coefficient should be positive because my graph is facing up. My vertex is at negative 2, negative 1. So it's really easy to know the outside numbers should be negative 1. And then it needs to be x plus 2, because x plus 2 means I should go 2 to the left. So I've gone 2 to the left and then down 1. So the equation for letter C represents the correct vertex and the correct transformations. Okay, so this is your assignment for today. In the slides that you had uploaded for you, you can click right on that. Also, task number 1 is to click on that Google form. You're going to answer all the different questions. I'm going to post this video in the Google form and as part of your materials. So if you're watching it from the materials, you need to go to the Google form and then click on it and answer the questions. This is not due until Sunday, but if you get this done today, on Tuesday, tomorrow, you will receive some feedback, and that will help you know if you need to try this assignment again and fix what you got wrong because you think you know what the answer is, or you can start on the next assignment, which will be on Wednesday on Desmos, help get you ready for your exit ticket that you will get on Thursday. Everything, once again, is due on Sunday. That exit ticket will be your grade for this week. So it's a really important thing to make sure you turn in and try really hard on. And so all the work that you do before Thursday, before you do that exit ticket, is really important because it helps you know, if you know how to do it, what questions to ask, and how I can personally help you if you're doing the work and taking it seriously. Also, if you are showing that you're putting effort into doing the work that I'm posting this week, I will also I will do it. I will curve your exit ticket grade for the week. So if you got a 75 or even a 70 on the exit ticket on Thursday, then if you've done all of the work and you've shown that you're trying to learn, and you got all that stuff in, maybe you came to office hours, I will add points to your grade before I put it in the grade book and before it gets sent in progress reports. I will have office hours on Monday and Wednesday at 1:30. So if you have any questions, need help with anything, you don't understand how to do something, you can share your screen. I can help you. I hope you have a great week.